Hello, Accelerated Chemistry students. This is Ms. Foley, and this is your Chapter 8, Section 1 notes all over molecular compounds. So let's first start talking about molecules and molecular compounds. So we know in nature only noble gas elements such as helium and neon exist as uncombined atoms. They are monatomic, that is, they consist of a single atom. Helium, which is less dense than air, is often used to inflate balloons because then the balloons will float in air. But not all elements are monatomic. O2 represents two oxygen atoms that are bonded together. Scuba divers breathe compressed air, a mixture that contains oxygen gas. Ionic compounds are generally crystalline solids with high melting points. Other compounds, however, have very different properties. Water, H2O, is a liquid at room temperature. Carbon dioxide and nitrous oxide are both gases at room temperature. Nitrous oxide is the gas that dentists use to make you relaxed. It's called nitrous oxide or laughing gas. That's what they use to help you relax while you're getting your teeth cleaned, or maybe you have to undergo some dental surgery. The attractions that hold together the atoms in O2, H2O, CO2, and N2O cannot be explained by ionic bonding. The main reason for this is because they are all molecules that are made between non-metal atoms. These bonds do not involve the transfer of electrons like ionic bonds do. Remember, ionic bonds form when combining atoms give up or accept electrons. Another way that atoms can combine is by sharing electrons. So atoms that are held together by sharing electrons are joined, when sharing electrons are joined by a covalent bond. So a molecule is a neutral group of atoms joined together by covalent bonds. So oxygen gas consists of oxygen molecules. Each oxygen molecule consists of two covalently bonded oxygen atoms, and we can see that in the picture down here and below. They're sharing for electrons. An oxygen molecule is an example of a diatomic molecule, which is a molecule that consists of two atoms. Other elements found in nature in the form of diatomic molecules include hydrogen, nitrogen, and the halogens. Remember, we memorized these way back at the beginning of the year. These are our special 7 elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those are your 7 diatomic molecules. Molecules can also be made of atoms of different elements. So a compound is composed of molecules, is called a molecular compound. Water is an example of a molecular compound because it is the molecule that forms when oxygen and hydrogen, specifically 2 hydrogen atoms, share electrons. A molecular formula is a chemical formula of a molecular compound. So a molecular formula shows how many atoms of each element a substance contains. So as we can see down here below, we have the compound glucose that contains 6 carbons, 12 hydrogens, and 6 oxygens. Butane consists of 4 carbons, 10 hydrogens, and octane consists of 8 carbons and 18 hydrogens. The formula of water is H2O, like we know. Notice that the subscript written after an element symbol indicates the number of atoms of each element in the molecule. And if there is only one atom, the subscript of 1 is omitted. And below is what the Lewis dot diagram for the molecule of water looks like. The molecular formula for butane, which is commonly used in lighters, is C4H10. According to this formula, 1 molecule of butane contains 4 carbon atoms and 10 hydrogen atoms, and the Lewis structure for that is shown below. So when we're representing molecules, we can use a molecular formula which reflects the actual number of atoms in each molecule. The subscripts are not necessarily the lowest whole number ratios, and that's okay. Note that the molecular formulas also describe molecules consisting of atoms of one element. For example, an oxygen molecule consists of 2 oxygen atoms bonded together, and its molecular formula is O2. A molecular formula does not tell you about the molecule's structure. In other words, it does not show either the arrangement of the various atoms in space or which atoms are covalently bonded to one another. An example of this would be when we look at the ammonia molecule here. We have a variety of diagrams and molecular models that can be used to show the arrangement of atoms in a molecule. So we have the molecular formula, which is just NH3. We have the perspective drawing, which shows how it will look in 3D. We have the structural formula in the bottom left-hand corner. Then we have the space-filling molecular model in the middle and the ball and stick molecular model on the bottom right. Practice drawing the structural formulas as well as the ball and stick models as we continue through this chapter. The arrangement of atoms within a molecule is called its molecular structure. The molecular structure of carbon dioxide shows how the 3 atoms are arranged in a row. It also shows how the carbon atom in each molecule is in the middle between the 2 oxygen atoms. So remember, the formula for carbon dioxide is CO2, and that means that one molecule of CO2 contains 2 oxygen atoms and 1 carbon atom. If we were to look at the structure of water, we can see that oxygen atom is in the middle between the 2 hydrogens, and the atoms of water are not arranged in a row. Instead, the hydrogen atoms are mainly on one side of the water molecule. And then we can look at the structure of ethanol, C2H6O, and that's more complicated. Each carbon is bonded to 4 atoms, and each hydrogen is bonded to 1 atom, and the oxygen is bonded to 2 atoms. We're going to have more practice drawing these and figuring out how they are arranged and the order that they go in when we get further into this chapter. So if you don't know how to do this right away, do not worry. I will be here to help you later on. And then let's compare molecular and ionic compounds. Remember, we completed ionic compounds and metallic compounds in chapter 7. So now we're going to compare the two. The representative unit of a molecular compound is what we call a molecule. For ionic compounds, the smallest representative unit was the formula unit. And remember that a formula unit is the lowest whole number ratio of ions in an ionic compound. So when we look at sodium chloride here, the formula unit will be the NaCl. That is what we consider to be also the molecular formula for our covalently bonded compounds. It is important not to confuse formula units with molecules. A molecule is made up of 2 or more atoms that act as a unit. No such discrete units exist in an ionic compound, which consists of an array of ions. Remember, in an ionic compound, the crystal is made of repeating patterns. So remember, we'll have cation, then anion, and cation, then anion, and then they make multiple layers, which will then represent the crystal lattice, which is the 3D geometric representation of the crystal. There is no such thing as a molecule of sodium chloride or magnesium chloride because of the fact that they are ionic compounds and they make crystal lattices. Molecular compounds tend to have relatively lower melting and boiling points than ionic compounds. Many molecular compounds are gases or liquids at room temperature. And in contrast to ionic compounds, which are formed from a metal combined with a nonmetal, most molecular compounds are composed of 2 atoms or more that are only nonmetals. And so if we were to compare water to sodium chloride, we would see that water can have a collection of molecules where we will have a crystal lattice, which will have an array of sodium and chloride ions. The molecule of water is the smallest representation of a single water molecule, where the formula unit of sodium chloride is just the 1 sodium ion and the 1 chloride ion. And the chemical formula can be written the same way. For water, it's H2O, and for sodium chloride, it's NaCl. Well, good news. This is the end of your Chapter 8, Section 1 notes. And as always, all the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition of the textbook, Resources CD, and pearsonchem.com. Thank you so much, and have a good night.